Hello and welcome as we're going to explore our user interface for our meat reading project. The purpose of this is to display the temperature of the meat and if it's done or not. So up here you can see the temperature history and as well as the toggle power switch for the user interface. Over here we're going to have a meat type list of pork, chicken, and beef that the user can choose from. And it's also going to display the current temperature of the meat as well as the degree at which the meat is currently cooked at as the output level. We're also going to have a picture that's going to be output just kind of as a fun thing as well as a more visual way to show what stage the meat is currently at in the cooking process. So we're only going to need a few things to run through the full process of setting up our meat reading device and actually putting it through use. So there's nothing too complicated as far as electrical components go. It's actually going to mostly be done on LabVIEW, which you can see in front of you now. And that's the temperature logger VI that we used in past labs. And we'll explain a little bit more on that later. In front of you now on the right is the thermocouple probe. And then next to that we have a thermometer that will be used to create our temperature curve for the temperatures of the meat. Now this is the NI board, which is going to be used to plug in the thermocouple and actually get the readings coming from the thermocouple from voltage form to be put into that temperature logger VI to convert it into something that we're going to be able to use for a temperature. So where you're going to plug this in on the NI board is actually marked thermocouple, which hopefully you can see in the video. If you're still kind of confused on where to plug it in, the end of the thermocouple has two prongs on the end of it like this, and there's only one spot that it can actually go into on the NI board in the first place. So we're also going to need a beaker and a hot plate in order to create our temperature curve with the increasing temperatures of the water. And this will be brought in through the temperature logger VI that I showed you before and now you can see in front of you now. So the first step in our process is to create the actual curve that our program will use to output the temperature of the specified meat that the user inputs. Like I said earlier, we're going to be using the temperature logger program already on the computers. We're only going to be looking at the thermocouple data, however. The other parts we don't have hooked up for this. So what we're going to do is slowly increase the temperature of the water in the beaker by turning the knob on the hot plate. And we're going to have the thermocouple and the thermometer hooked up so that we can track the temperature on the thermometer as we take the readings on the thermocouple. So back over on the VI, we are going to input the temperature in the bottom right corner at every 2-degree interval, pretty much starting below uncooked meat and well above cooked meat. So that way on the Excel file it'll output the temperature with the thermocouple reading so that we can create an accurate curve for the output of the meat. The next step of the process is to use the raw data put out in an Excel sheet in order to create the curve that we're going to use for our program. The actual logger.vi program created about 8,000 Excel points because we had it running continuously. So what we did is we took the average of those points at each temperature and created this condensed set of data to use for our actual linearized line. So this is the line that we got off these Excel points. There's a little bit of variation as you can see with the temperatures as it goes up. So what we did is created a linearized line going through these points to get the actual equation of the line that we could use for our program. And as you can see up in the top right corner, here's our equation of the line with an r-squared value of approximately 0.99, which means that it's actually a pretty accurate reading without much variation in the data itself.
As indicated, we created a calibration curve in order to take input voltages from the logger used in previous labs and convert those to temperatures. In order to do this, we went into the background VI of the logger that we used in previous labs and used a numerical indicator to grab the voltage output. We were able to do this and then basically make it into a sub-VI. By putting it into a sub-VI, we were able to take all of the contents of the VI we used for the previous labs and put it directly into our user interface VI. As you can see here, what it will output will be the temperature. The way we get to this temperature is we use a calibration, as discussed previously, with the VI output using the voltages, and that is converted into a given temperature. That temperature is then passed into a case structure, which is just like an if statement. Based on the if statement, determining whether it's pork, chicken, or beef, the computer then analyzes what temperature it is at. We inputted all of the values for well done, medium well, medium, rare, etc. for chicken, pork, and beef, and based on what output of the temperature compared to these values, we were able to determine what our meat would be at. In addition, with outputting the given statement of medium, the user interface will also be outputting a picture. This picture will correspond to what the meat should look like when it is at a given level of cooked. As you can see here, we used a simple wiring diagram with JPEGs that were downloaded from the internet in order to create this element of the VI. This will be then outputted on the home screen, which the user will actually be seeing. In conjunction with the temperature that their meat is at, they will be able to see this picture. As you can see here, a fully cooked piece of chicken is at a given temperature, and so our user really understands what meat they're cooking, what temperature it's at.
So in conclusion, that was the full process of our project and has every aspect needed in order to output an accurate reading of the temperature of the meat. Thank you.